Hi and welcome. This next project will probably be a quick one. It involves making 3 parts out of mild steel for that aerospace client of mine. And the parts are interesting because they're fairly small actually. This is a blown up drawing. Here's scale parts 1:1. So they're pretty small parts, 1.2 inches, 0.8 high at the highest point, 0.5 at the middle point with a fairly narrow slot. They're not particularly thick. They're between 0.25 and 0.38 thick. That specification is pretty wide. They've got a 30-degree angle cut into it. And so I'm going to try and find a way to make this a quick and efficient process. I'm going to try and make all 3 parts simultaneously. So I'm going to dimension this stock. Then I'm going to head over and remove some material, cut the angle in it, try and cut the slot in all the parts simultaneously after I finish this end off here. So we're going to remove material down to about here, put the angle in it going up like this. I guess I could just draw that, right? So you can see what's going on. So I think I can do multiple parts at once if I sort of cut into it like this, and then it's got the slot cut into it somewhere here. And then what I'll do is I'll take this guy over to the bandsaw, cut him a little bit big, take the remaining piece over the mill, clean up one side, cut off another one, take the mill, clean off one side, cut off the remaining one, then take those 3 parts and finish them to final thickness, which is a pretty wide dimension. And I'm going to see if I can get that done much faster than I normally would. Doing these individually would take a lot more time, so I'm going to try and simplify this. And let's see how it works. All right, so we've got a raw stock here that I dimensioned off camera. I didn't think you'd want to see that. I still need to clean up the ends on both sides because at some point in time I'm going to want to clamp it between faces. And in order to do that, I want to make sure these edges are flat so it doesn't cant or anything like that. So the first step is going to be to take down some material. You can see the profile there. So we're going to leave a 1/2 inch on one end going in like 0.680, and then we're going to turn this at 30 degrees and we're going to remove across 0.6 in a straight line, which is why I redid the CAD drawing. You know, a lot of times when I want to know a dimension like that, you could either use trigonometry or you can just take your CAD, rotate the part the appropriate angle, and then calculate the length that way. Or, you know, CAD also will let you do length specifically along an angle, but I usually prefer to rotate so that it helps my mind keep track of what I'm trying to do. So this first operation, we're just going to take a little bit of material off. No particular amount, I'm just going to clean it up. So I'm only taking 5/1000 cuts. So you'll notice when I go one direction, it takes off material. Then, when I go back the other way, it takes off a lot of material again. That means that that something is deflecting. Either it's the solid carbide bit, the mill. It's deflecting enough that even at the 5/1000th depth of cut, it continues to remove material, which I find to be common. Maybe my mill is nowhere near rigid enough. But what I do is when I want a really good finish, I make multiple passes until it quits taking material. And it tends to do the best taking material off on climb milling like I am right now, rather than conventional milling going the other direction, which sort of makes sense because conventional milling, the sharp edge of the blade has to be able to bite into the thinnest section of material. With climb milling, it's biting into the thickest amount sticking out, so you're going to be able to get it down somewhat smaller. There we go. So the next is I've got to basically remove, I've got to go in 0.680 inches from this edge, which is why I found this edge here. So I got to go in 0.680 and I've got to remove 0.3 inches worth of material, which is why I left some of this sticking out over the end so I could get my mics on here. So after this pass, I'm going to measure this thickness, then I set my Z0 and figure out how much farther I need to go, because this needs to be 0.5 I took about a tenth, maybe 75 thousandths off first pass just to test the waters. All right, next up is to put the 30-degree angle in this guy right here and remove some material here. So the way I'm going to get the 30-degree angle is I've got this adjustable angle setting block here, which actually lets you set to minutes, which is pretty amazing, through a vernier. However, I don't need that kind of accuracy. This angle only needs to be plus or minus 5 degrees. I've got a couple of ground spacers here that will push this out from the edge of this enough that I can machine all the way to this corner and not hit the block here. And I'm going to mount this guy in here. They also space it up enough that I just barely have clearance to above the base of this. It's going to be really tight. Got to worry about hitting my vice jaw a little bit. I might even want to add some spacers here. I'm probably going to do that just to put it up a little bit higher, which means it won't be grabbed as tightly, but I don't want to hit my vice jaws. That's a huge no-no. So this is the 30-degree angle we're looking at, and I showed you before how I could find the width of that, but I took it one step further. So if we look here, in CAD, I put the removed material that would be left over after the first operation, which was this one right here, that slot we just cut essentially, or relief, and put it at an angle. So I know my approximate depth. Now, actually getting the cutter to find this exact sharp edge is highly unlikely if I had to do this within, thousandths. But what it will give me is a fairly good rough estimate of the depth I'm going to have to travel in order to clean all this material up. So that's what I wanted. I know that I've got to go in about 0.6, well, exactly 0.6, and the depth is going to be about 0.26 if I could line up right on the sharp edge here. So CAD can be really helpful in setting up your milling operations. And I'm not going to dial in the exact 260 because that peak probably isn't a perfect dead sharp point, so it should be a little bit less than 260. It left a burr right down the middle, which I'm going to have to manually remove. So I'm going to go do that with some sandpaper. The spec's called radius as necessary, so I think that should be fine. And we got right up to this edge. It's now razor sharp, so that's good. There's our profile. I think we're ready to move on to our next step. All right, so next up we got to do a slot in here. And I know the drawing is mirrored. It's actually sitting like this, but that doesn't matter because the reference is 0.25 for the slot center off the bottom, and the first hole radius is 0.25 off this back side here and continues to 0.910. So I'm going to drill some undersized holes first. I am going to try and get this very close to 190, but first I'm going to pre-drill these two holes and a couple in between, and then we're going to take an end mill and clean it out. My end mill is a little bit under 3/16, so that'll give me some clearance, and we'll just go side to side to fix the slot width. All right, so to get the final radius right, I am going to drill with a proper drill. I am going to have to lower the table to do that. But first I'm going to center drill, and then I'm going to pre-drill with something a couple sizes smaller. Now my goal is to drill these fairly deeply so that I can cut all my parts. I can just take the saw and slot these parts, cut these parts off one by one. So I'd like to do all the slots at once. I don't know if that's going to be feasible. I don't know if the end mill will even work that deep, so that's a big unknown for me. So we're starting with a stub drill here. There's an art form to doing extremely deep holes, and I am not familiar with all of the tricks. So it's entirely possible the drill bit will wander. I tried to minimize that by getting the hole started straight to begin with. And I realize being a vertical configuration like this is not a very stable way to mount a part. but I am going to be going towards the fixed jaw, and I am not going to be trying to apply a lot of force. If I had the mill going this direction, I think that could be a problem. You could tip the part pretty easily, but we won't be doing that. So the end mill I'll be using is 11/64, which is a 64th under 3/16, which is 1/875, which is still smaller than the hole. And how did I get an end mill 11/64? I'm looking on eBay. I'm giving you another one of my secrets. When I'm looking on eBay, I will look for end mills in odd sizes that no one wants because they're odd sizes, and buy them because they help me in projects like this, and they're often a lot cheaper than a very similarly sized normal drill bit. So if you just went up 1/64, the price of this may go up on eBay quite a bit, only because 11/64 is so strange, not too many people want it. All right, so now we're just going to plunge cut a bunch of these holes. I'm just going to walk the y-axis as I cut. So I'm going to try and go in the middle of this spacing here to take as big a bite as I can, because ultimately I want to go fairly deep. Ooh. So the holes I drilled are far deeper than the end mill is plunging in, and what that buys me is the ability to have the chips fall on those holes initially. So I will have to clean those out. Now we're going to try and just straighten up the parts I just cut. I'm going right down the middle right now. Okay, now we're going to clean this out, and then we're going to widen this slot up a little bit. Now I need to measure the slot. It looks like I still underestimated the size of the drill bit because deflection still cut into the edge. I went down about 10 thousandths, which is only 5 thousandths side now in retrospect. Poor choice. The drill bit should have been even smaller. My intermediate drill bits should have been even smaller, so that's my bad. I'm not going to have a very smooth edge of this. This is a .190 gauge block. It's one of the round blocks. It's not as high a precision as some of the other ones, but it's more than accurate for this. This isn't a super precision anything. And so it won't even start. So we're going to open it up a couple thousandths aside and come back. There we got a decent fit on the gauge block. There is, I think, a burr or something down a little ways because it should just fall all the way in the slot. So I'm going to just go over my edges one more time, and then we're going to go to the next step, which is just to cut off a piece of this. Here you can see the slots with the drill holes going much deeper. And it cleaned up all right. Next time I'll go even smaller because this wasn't small enough to make it perfect. So I'm a little disappointed at that, but live and learn. All right, the last step, we have all three of these with the faced side down and the rough sawed side up. And I left quite a bit of material to remove, well, quite a bit being like 20 thousandths or 30 thousandths, or even a little bit more depending. And so we're going to go this direction into the fixed jaw. I can't over tighten the vise or I'll just squeeze this pocket open and bulge it. So we are not going to do that. All right, so I'm a half a thou under 0.38. 0.3795, and we're going to call that good. That's the maximum thickness, and I'm going to deburr these and we're going to call it good. Here's the final parts, and they turned out okay, adequate. The face milling finish is really nice. I like that even on this mild steel. But the slots have a lot to be desired to be perfect. For one thing, the drill bits I chose were only 12 thousandths underside, which is only 6 thousandths aside, and apparently a little bit of drill bit deflection there caused them to touch within the bounds of outside the bounds of the slot, and so can't get the slots perfectly. I did do a climb milling cut in that direction around the outside of this to clean this up the best I could. Climb milling does a better job than conventional milling as far as surface finish is concerned quite often, but that still wasn't enough to take some of the problems with the end mill out. Also, the milling cutter having a long cutting tip on a small milling cutter like that leaves a little room for vibration, so you don't get a perfect finish either. I also did not catch the tangents of the semicircles on either ends perfectly, and I would like to do a better job on that in the future. I mean, I'd love to get a perfect slot, and these are not that. I left the stock long on purpose, so I had plenty of room to hold in the bandsaw when I wanted to cut the pieces off. And the advantage of that is you can make more of these out of it in the future, and I'll give this to the customer, and they can drill and slot the extra material as needed, or have someone do it, and have plenty of room to make more parts if they need to. I learned a ton in this project, and going forward, hopefully I'll improve my skills, and that's why I take these projects. They're a bit challenging. They're sort of simple manufacturing projects, but getting them really clean can be hard, and I've got a lot to learn. So that's one thing going forward. I always like to learn something. Anyways, I appreciate you joining me on this journey. Hopefully you learned something too, because I definitely did, and I hope to see you next time. Thanks for watching.